We're going to use dimensional analysis a lot in this course. Dimensional analysis involves performing calculations through a series of smaller steps guided by the units involved in your problem. To introduce you to the topic, we're going to do a very non-chemistry example in hopes that the ideas transfer from this easier to handle everyday example to a more difficult chemistry example later. Any dimensional analysis problem requires that we know a few things. First, what have we been given in terms of starting information in the problem? Second, what do we need to solve for at the end of our problem? And what do we need to get from point A to point B? If we know we need these pieces, then let's tackle them. Our question tells us that we're worried about the month of July. It also says that we need to determine how many seconds there are in July. So this is going to be our unknown. Lastly, we need some conversion factors to help move us from where we are unit-wise to where we need to be unit-wise. I'm going to use all of these in the interest of demonstrating the technique, but some of these could easily be combined to shorten your calculation a bit. Our dimensional analysis calculations will always begin with our given quantity. If you happen to be given multiple values in your problem, then you're going to want to start with the quantity that has a single unit associated with it, like month here. Now, let's begin working away. Since we eventually need to get to seconds, we first need to move away from the unit month to a smaller unit. Since we know July has 31 days, working with a 31 days in a month conversion factor is a good first step. You need to not only know what you need as a conversion factor, but also how you need to use it. The unit month here is in the numerator, so if I want to move away from the months, the unit month will need to go in the denominator in my next step. If I use the conversion factor in this way, my units end up canceling the way I want them to, and I'm left with days. If I happen to flip my conversion factor over and use it the wrong way, I get these silly units that don't make any sense. As you're working problems, you'll always want to include the value you're given as well as the units that go with them so that you can double check your calculations more quickly. Our conversion factor will be placed into our equation thusly, and if we stopped here, our months would cancel and we could calculate a value in terms of days. But we're not stopping here, so let's keep going with our converting. The next step down from days is going to be hours, and we know that there are 24 hours in one day. Again, watch the placement of the units. Since I'm moving from days to hours, the days need to go in the denominator so that I can cancel that unit out. Right now, any value that I would calculate would be in terms of hours. Continuing along, let's move from hours to minutes, working to ensure that our units cancel. Any value that we would calculate using these conversion factors would be in terms of minutes. And lastly, move away from minutes to our wanted quantity, seconds. When you think you've set up everything correctly, review your units and double check that everything is in the right spot and that you are canceling out the things that you intended to cancel out. Here, we can see that we're canceling out everything but our seconds unit. Once you have your problem set up, like we do here, you have to actually calculate it. The process here is fairly straightforward. All of the numbers in the numerator get multiplied together. The first one here is the implied 1 in the month term. Separately, all of the numbers in the denominator are going to be multiplied together. Note that there are only values of 1 here, but we will get to the point where there are non-1 values, so your simplified denominator will actually matter quite a bit. Once you have your fraction set up, you can simplify it, and in this case, we'll get a big old number. While I will always have to tell you how many values to report any answer to in Canvas, This answer has an absolutely ridiculous number of sig figs, especially given the fact that all of the values in the problem are well known and their values are not counted towards the overall sig fig count in your final answer. So this supergiant value is probably better represented with zeros at the end instead of actual values. It's also best represented in scientific notation due to its large size. Again, I will have to tell you how to report your answer on a quiz or an exam, so you won't have to guess which format I want or how many decimal places to include. But it's worth knowing when there are way too many or way too few sig figs.